welcome back again. So today we will be doing, today's topic we will conquer is the definition of a derivative. So you know how when your professor or teacher or whatever makes you, instead of just simply using the power rule to take a derivative of this, it's just 1/2. They make you go through this whole tedious, stupid, in my case, process. I think it's stupid, called the definition of a derivative, where you plug f of x into this, and they for some reason say, oh my god, it's so easy, and they give you an easy, they give you an easy example because that's what they can handle, and then they throw you a quiz and it's completely different. It's like a whole another hard problem that they expect you to learn. I don't know, I don't like those kind of teachers. So today, another thing is that this is what they say to you. This is what's going to be on the quiz. What's going to be on the quiz? I'm sorry, not that. I'm getting confused. Okay. This is what they usually say to you. That's what they say to you. I'm not going to say which professor because it's mean. So this is what they'll say to you. They'll say, okay, what we learned so far. I'm confused. What do you mean what we learned so far? Like, the start of the semester? Right now? I don't know. And that's what irritates me the most. So, I feel bad for you if you're in that situation. So, enough about that. We will learn this definition of a derivative. So here we have basically what it is. This is the formula definition of what a derivative is. Limit as h approaches infinity, f of x plus h minus f of x all over h. And basically, you kind of want in the end, you're like, h is sort of to cross out, and that's how you will get your derivative. So here we have f of x equals 1/2 x minus 1/3. So basically, you'll plug here. So I'm going to start over here. Here. Limit as h approaches 0. Just put this little thing right here. And you'll have 1/2. And basically, you're going to plug x plus h into the x. So then you'll have x plus h minus 1/3. You still have to sort of basically what you're doing is plugging x plus h into x, and you still will keep the 1/3 minus, make sure you put a parentheses or bracket, f of x, which means minus the original, which is 1/2 x minus 1/3 all over x. All over h, actually. And so now, from here, what you can do is just distribute 1/2 over. So basically you'll have limit as h approaches infinite, as h approaches 0. I'm so getting confused. And then you'll have 1/2 x, because you would distribute, plus 1/2 h minus 1/3. Oh, why do I always do this? I don't know why. Let me just put it down here. I hate myself. So 1/2 x plus 1/2 h minus 1/3. And then from here, distribute the negatives over here. So then you'll have minus 1/2 x plus 1/3. All over h. And so here, as you can see, we have lots of terms are going to cancel out. We're going to have 1/2 x cancel out. We're going to have 1/3 and 1/3 cancel out. And then we're going to be left with limit as h approaches 0 all over 1/2 h all over h. And remember, this can be rewritten as limit as h. Don't just plug in 0 because right away, because you're gonna think, okay, yeah, it's 0. No, it's not 0. So remember, this is h all over 2 all over h over 1. And basically, it's just 1 over h. These cancel out, and then basically you'll have left is 1/2. And so, yeah. Basically, this is your answer, 1/2, because realize if you do power rule for, just throw this pen, realize that if you do power rule for this, it'll be f prime of x equals, of course, 1/2. And so the minus 1/3 is just going to eliminate and turn to 0. And so, yeah, this is how you do it. Basically, what you're doing is just plugging x plus h into any of the x's, and if you have like any other like little minus 1/3 or minus 5, just you still have to like sort of leave it out. Just plugging x plus h into the x, and then minus the original all over h, and then you'll get your answer with a little distributing, a little algebra, and you'll get your answer, which is 1/2 for me. I don't know if it's 5 or 6 or something from you. Well, so anything from you. Well, it's 1/2 from me. So anyway, now I hope you've conquered this lesson today of the definition of a derivative, and I don't like this at all. And I'm only doing this because I want to help you with what I went through with this sort of tedious process. And so now I hope you've conquered it. Said that a bunch of times. So I'm gonna go now. So